Very warm welcome to all of you. Uh, it's my absolute pleasure and privilege to introduce the speaker today, Arijit Mukhopadhyay, an esteemed colleague and a dear friend. Arijit graduated with a BSc Honours in Chemistry in 1991 from the University of Kolkata. After working as an industrial chemist for 2 years, he went on to do his PhD at the University of Jodhpur, Calcutta. Following this, he was awarded a prestigious Marie Curie Fellowship in the Netherlands to do his postdoctoral training from 2004 to 2007 for 3 years. He then moves back to India to join one of the country's most prestigious research institutes, the CSIR Institute for Genomics and Integrative Biology, where he works as a senior scientist for 10 years, or nearly 10 years. Then back in Salford here in 2016, he joins as a lecturer and then goes through to be a reader and now the professor of precision health. A multifaceted person, an inspirational teacher. Students and staff rate him very highly. His modules are very popular. An accomplished scientist. The pursuit of scientific excellence and impact have been the hallmark of his career. Of course, his passion for collaborative endeavors is reflected on on the diversity and the wide audience here from practically every school here. A very respected mentor for students and junior colleagues, and committed to academic citizenship. He, together with another colleague of ours, Dr. Caroline Topham, pioneered and led the student well-being lead roles at a time when there was a lot of turbulence in the school, supporting a lot of colleagues. And of course, those of you who have been to his home and met his wife, Sangeeta and Ahana, will not fail to notice a philosophical side to him, one that encompasses a deep regard for culture, spiritualism, and core human values. So without further ado, may I now invite to deliver his inaugural professorial lecture, Professor Arijit Mukhopadhyay, and a rather enigmatically named title, Rearview Mirror on Successful Failures, Privilege, Purpose in the Journey. Arijit.
Thank you, Roshini. It's always unnerving to hear about yourself, but thank you for that. Thanks all of you. It means a lot that you decided to spend part of your evening for this. That means you did not do something else. So thank you for that. And thanks to Lucy and the team here for dealing with me for the last couple of months to make sure all my requests were entertained. What I plan to do, I plan to take you through a journey that I have been through, kind of looking back, and tell you where it all began and how did I landed up in Salford and in this room today. And what it all meant to me and what kept me driving. When I was doing it, much of that did not make sense to me. But as I look back, it made sense that how it all fits together. And as Hiroshini pointed out, the enigmatic title, my goal, one of my goals would be to, I think the modern world is obsessed with success. My goal is to highlight that failure is essential for growth. That's what I plan to do. I'll do this in 3 parts. I'll first talk about privileges. You can't do anything really without having some good luck for which you don't deserve any credit. So I'll talk about that. I'll talk a little bit about my journey, my failures to be exact. And then towards the end, I will talk about a few stories from my research that the connecting theme about those stories, I'll tell you 5 stories to be exact, and connecting theme about through those stories is that they all enrich lives of other people. So that's the kind of the plan. Starting with my privileges, I come from a country which has 1.4 billion people, 50 different scripts. I read about 3 of them, and more than 300 languages. Just try to imagine the diversity of the country itself. What I show here, just to kind of point out, is that it's a poet, one of the greatest philosophers ever lived, and his name is Rabindranath Tagore. He has shaped the psyche of the whole country, and of course for our community. I'm fortunate to be born in the same city as he was 150 years ago. And the text on the left, which most of you cannot read, is written in Bengali, which is my mother tongue. And the gist of it is translated into English below the picture, which essentially says that India is the melting pot of humanity. And he wrote this in 1910. And I show you later on how through genetic science, we proved this philosophy. We showed through genetics that India indeed is melting pot of humanity. So that's my first privilege, to be born and raised in such a diverse country. So I come from a city called Kolkata or Calcutta. Just to give you a perspective, that's the highlighted with yellow star. That's where it is, towards the east part of India. And just for the context, on the far left, you see Manchester, which you probably can't read. So it's about 10,000 miles away from here. That's where I come from. It is also a privilege to be born in that city, apart from being born in the same city as the poet I just mentioned, because it's a city that celebrates knowledge and culture. I'm not claiming that it's the best city to live in the world, but the city is a great incubator if you end up being an academic. I deliberately did not name all the names on the picture. The people on the left of the slide are those who won a Nobel Prize for various subjects, from medicine to peace to literature. And people on the right didn't win Nobel Prize, but they were somewhat even far greater contribution, no less than Nobel laureates. And those overall, it ranges from filmmaking, music, art, culture, science, statistics, math, quantum physics, you name it. So when you grow up in that city, knowledge, the business of knowledge is celebrated, right? And just to give you a glimpse, a video should play in a few seconds. There's just a random corner in a very, very busy street corner, which I find very unique. I've not seen it anywhere in the world. So you hear that sound, the noise, and you look at the people playing chess. And when I say it celebrates being cerebral, people play chess while they're waiting for their bus to arrive. And when the bus comes, they just go up, get their bus, not even say hello or goodbye. Next person waiting come and continue the game. This is what the city celebrates. So that's my privilege, that I come from such a place. More direct privilege is to be having parents that build directly my scientific temper. This picture is a few years old. This was on my parents' 50th marriage anniversary. And so my father is a retired professor of anthropology. So it's a privilege to be born in an academic family. So academia was not something unknown. It was very much known. So he will turn 86 on Saturday, and he still works longer hours than me. So I directly learned work ethics from him, and scientific thinking, scientific rigor from him. He has written 22 books, as you see it on the side, right? And all the books are in the market and they're sold. I have not written one. Right? This particular book is worth mentioning in this forum. This is a book I co-authored with him. So I'm very proud that that happened. But when I think back about my growing up period, my privileges, I think my mom, who is a student of humanities, arts and humanities, she actually built my scientific temper. When I was growing up, she would call me in the kitchen and ask me to explain a phenomenon that is happening in the kitchen. The water boiling or something happening, not happening, something getting burned. She would ask me to explain scientifically. So I had to struggle learning to apply my knowledge, textbook knowledge, into application. And I think looking back, that has built my temperament and attitude towards science as I am today. Also, I showed you the small clip about people playing chess. My mom taught me how to play chess, and she's the one person I could never beat. Right? So that's a privilege coming from such a background. My father kept plotting something that I'll explain in a minute manually on a graph paper. Those of you younger in the audience would not even know what that is. People older in the audience would know what that is. That's a graph paper which you manually plot. What he plotted for 13 years for me, and then another 7 years for my sister, who you see at the bottom of the graph. He plotted the grades we got in each year, and he started when you were in year 3, and it ended when we graduated. And you see the marks are not mentioned there. Right? So early on, I got introduced to the concept of the journey and not the destination. Grades didn't matter. Are you growing? That mattered. I didn't know what he was doing. I was just happy as a teenager that I never get bugged at home for not getting good grades. Right? It's only later on when I started hearing from the current thought leaders the importance of journey and not the destination, importance of showing up is actually growth, not the success. It made sense what he was doing. And he not only did it for 20 years, he also kept it. So I got it scanned by him and sent it through. So it's the journey, not the destination. The concept came from there. So that's a privilege. My wife, who I met or got married to almost 25 years ago now, she's here, Sangeeta. And our daughter, Ahana, who is also here, thank you. They are my biggest supporters and the harshest critics. So they make sure that my growth never stops. Thank you for being here. That's a privilege as well. So family shapes everyone. But today, if we are celebrating an academic achievement, I think the people I want to directly credit for are the people on this slide. Some of them, at least one of them is in the audience. They are the 15 or 16 people who have completed a PhD with me in my entire journey. So it's their direct contribution which led me here today. There are many others who have engaged with me for research, but continuing to do research. And again, some of you are in the audience. You are by no means less important. I just chose to show pictures of those people who have spent 5 years with me, dedicated 5 years with me. So they're the real heroes for what I'm going to talk to you today. I don't know what they got from me, but I know for sure that I got more from them than what they got from me. That's for certain. So those are my privileges that I would like to acknowledge standing in front of you today. So my journey, despite coming from that kind of a family, my goal was not to go to university. My goal to play cricket for India. You know, cricket is like a religion. Those of you who follow cricket, you know cricket is a religion. So that's me on the left of the picture when I was 17 years old, when I was selected to play for Bengal, right? Which is a big deal. Why it's a big deal? It's a state in India, but why it's a big deal? Those who follow cricket would recognize the other person on the picture. His name is Saurav Ganguly. He was captain then of the team that I was a part of. He later on became the most successful captain India ever had. So I couldn't make it the way he made it. So that was my first goal in life. And it still hurts me that I didn't make it. But when I look back, that was a very important failure. It's an important failure because when I did very well, but the team lost, I cannot feel good. When the team lost, the team won, and I did very poorly, I had to cheer with the team. And no matter what, I had to show up every single time with the same effort and same concentration and same motivation. So that taught me a very valuable lesson. Again, that journey is more important than the destination. Showing up every time mattered more. And that shaped me who I am today. So hence the successful failures. Niroshini already mentioned at the beginning that although I do biology today, my initial journey was in chemistry. And the reason was that because I focused on cricket, I decided not to study further after high school. My grades dropped, obviously, right? So my well-wishers then convinced me that no research organization will accept me. I should take a subject where I have more employment opportunities. So I studied chemistry, enjoyed it. I went on to do a master's in inorganic chemistry, farther away from biology, enjoyed it. But then I landed up doing PhD in genetics, and I'll tell you how. How did that happen? So because the focus was to get a job, I did get one. That was second goal, that okay, I accept that I cannot become a cricketer, so I become an industrial chemist. So I got a job in a company. It was well paid, and I had a furnished apartment, and I had a vehicle that took me from and to the job. But I didn't enjoy it. I did it for a while, but I didn't enjoy the job. So there were three, but I was convinced that I cannot do research because I didn't get good grades. So I thought, okay, this is my life. I have to do it. And there came three of my friends who I did masters with, particularly the guy on the left. They kept on telling me that I should do research. I should think about research. And what I learned from that is that when we hear self-esteem, we think it is supposed to come from within self. But the initial catalyst is always externally stimulated. You need someone else to tell you you are good, for you to believe that you are good. Right? So they did that to me. So they removed my limiting belief, and they convinced me that I should try for research. And the guy that you see on the picture, the person on the left, Kaushik, he actually made sure that I do. He was doing PhD in this fascinating institute in India, 2,000 kilometers from my hometown. And he said, we have a position here, come, leave your job and come interview for it. If you get it, then you have at least some exposure to research. It's a chemistry lab, nothing to do with biology. So I came. And it was a difficult decision to make because to move there, not only I moved 2,000 kilometers away from home, I took a 80% pay cut. I was having a stable job, it's a permanent job, the good salary. I came on a fixed term contract with only 20% of that salary. So it was a hard decision. And everybody else, including me, thought I was really being stupid. Right? And so I joined, and again, it didn't work out. The reason for two reasons primarily. I didn't enjoy that either. Although it was comfortable because I knew the subject, I didn't enjoy it. Right? And two, the fixed term contract ended, and I didn't manage to get a further funding or a fellowship for a PhD. And I still remember so it ended in July 1999, as it says in the slide. I still remember that in that summer, so May, June 99, there was 1 week where in 1 week, I got 7 rejections. Right? And I think it's important to mention, especially for the younger member in the audience. I got 7 rejections telling me that I cannot do a PhD. So I came back home. I traveled back 2,000 kilometers. So I could not become a chemist either in industry or in academia. Then completely by chance, in my hometown back in Calcutta, there is another very famous research organization. I met Professor Kunal Ray. Complete coincidence. He came back to the city, to the country, after spending a long time in the US, hoping to set up a lab of human genetics. And he wanted to have an interdisciplinary group. And I ended up becoming his first PhD student. I still don't know why he hired me. I'm glad he did. So in that happened, and you can see at the bottom, it was quite an all right PhD in terms of productivity. And even that, again, I felt very stupid, and everybody around me kept telling me that this is a very wrong decision you're taking. So I started a PhD in a subject that I had no clue about 3 years after completing my master's. And nothing made sense to me, but I felt excited. And 3 months into this program, I was called by my previous chemistry lab that they now have a funded PhD position that I could join. So it was really, really hard for me to decide not to go to the comfort zone, but to stay in the discomfort. Just because I started liking it, I had no idea it will work out. It did. And that took me another 9,000 miles away to the Netherlands, where I got a Marie Curie fellowship to go to Nijmegen. It's a city towards eastern side of Netherlands, towards Germany, and it's Radboud University Nijmegen, had a Nijmegen Center for Molecular Life Sciences. They had a department for human genetics. So I got a postdoctoral position there. My mentor was Professor Franz Kremers, one of the most wonderful human beings I've ever come across. And the overall project was called RETNet, as it says so on the slide. And Professor Shomi Bhattacharya from UCL London was the overall coordinator scientifically. So both of them played a huge role in my scientific career, right? And that was quite successful as well. I'll tell you a few stories from each of these stages of my academic life later on. And then again, I moved back another 9,000 miles towards my home country, not hometown. Now I'm in Delhi from Calcutta, which is 2,000 kilometers apart from each other. Just to give you the scale of the cities I'm talking about, the size, the crowd. Calcutta has about, a city has about 18 million people. Delhi has about 20 million people. Right? That's the crowd you are thinking about. That's the city, the buzz in the city, if you will. So there I become a mentor. I was there for 9 years, and it was a beautiful building, and I still miss that job, to be very honest. I had a great, fantastic group of PhD students there who I had a lot of fun with, and that was quite successful as well, scientifically. Lots of failures, but those are the failures every academic is familiar with. You fail in getting a grant, you failing in publishing a paper, you failing in experiments. So that's the failure any academic person will understand. And 2016, I come to Salford. Primary reason was at that time, my family, my wife and my daughter was in the UK. So that was my motivation to move. So I come to Salford. And I was very unsure in the beginning. I've never taught an undergraduate class. Some of you who hired me is in the room. Thank you. But there's if I have to name one person who really made me believe in myself again, that was Professor Sheila Pankhurst, who was one of the longest serving deans, as long as I've been here in Salford. And those of you have worked with Sheila would know what I'm talking about. When I doubted myself, she believed in me more than I believed in myself, right? And like any academic, I wear many hats. So all the academics in the room would relate to it. So of course you do teaching and research, but you wear many other hats that I do as well. But it was Sheila who really made me feel that, okay, I did it in Delhi, I did it in Calcutta, I can do it in Salford as well. Salford has a very unique feel, and I'm saying it with full awareness of moving in multiple places in the world. Salford makes it very comfortable to approach people for collaboration. And these are the people on the screen, on the top part of the screen, are people with whom I currently have an active collaboration, meaning either we are writing a paper together, a grant together, have a student together, stuff like that. So there are many more colleagues who are having conversations together, and that might lead to collaborations in the future. So it's really, really easy and comfortable to have collaboration that I never felt anywhere else in the world. And at the bottom is my current research focus. I'm very fortunate to be part of a large research team which originated from School of Health, and I'm part of a very, very multidisciplinary team, which is hopefully some exciting science, which I'll be able to talk about at some point later. Before I move on to stories, I also acknowledge external collaborators for a minute. I will talk quite a substantial chunk of time about a particular project that I'm doing at the moment with collaborators in India. So those are the collaborators on the top. And at the bottom, there are other collaborators. They're from different parts of the world. They're from industry, from NHS. Again, I will not be able to mention each one by name and why, what we are collaborating on, but I'm very, very grateful for all of them. Similarly, all the science I'm going to talk to you about soon needs a lot of money, and several people have believed in our work, both in India. So the top part of the logos that you see are from India. The bottom part are primarily from the UK, including EU funding that I received when I was in postdoc. So all this research, all this talk I'm going to give you requires a lot of money. So deeply thankful to anybody who has believed in the projects and funded. With that, I will move on to the scientific stories. I'll try to keep the technicalities as less as possible. And as I said, I'll tell you 5 stories, and the connecting theme is that they somehow enrich lives. And the enriched lives can be a whole community, whole population, or a community, a family, or even a single individual, right? And we enrich life through genetic research. So that's what I do. To understand, I need to tell you about the philosophy that drives me. I thrive on change. So when I looked it up, that who said change is the only constant, it turns out there was a Greek philosopher, Heraclitus, who said it in 500 BC. The change is the only constant. So that's really dictates my life as well as my research project, choice of research project. And if you think of at the cellular level, we actually change every single day, literally, right? So I'll explain what I'm showing here in a minute. So as a blueprint of a house is essential, but the blueprint is not the house, right? And when you change a tap, a painting, or a little bit in the house, you don't change the blueprint. Similarly, DNA is the blueprint of our life, which makes who we are, but everything is not contributed by DNA, right? So what you see on the left is that DNA is really the blueprint, that the innermost core of what makes who we are. And there are multiple layers of information after that. And the complexity increases as we go to the outer layers. And don't bother about the technical jargons. The outer layer is called phenotype. Phenotype essentially means something that you can observe and measure. So your height is a phenotype, but blood pressure is also a phenotype. So the stories I'm going to show you today, talk to you today, are where you have a change in the blueprint, change in the DNA, and how that can change someone's life in a good way. The first story is when we deal with the entire population of India. So this was a landmark project conceived by Professor Sameer Brahmachari, who you see on the slide here. So he is the most courageous and most dynamic scientific leader I've ever come across. I was very fortunate to work with him directly when I was in India, in Delhi. What we did, why I'm showing you this as a story. What you see on the map, so the background of the map of India, the colors, shows the linguistic backgrounds of the country, right? So blue is the Indo-European language. brown is the Dravidian language, green is the indigenous population's language, and the pink or the light pink you see on the east and the north are the Tibetan language, right? And the understanding is that if you take people, sample people, and look at their genetic makeup, it should match with their geographical locations and their linguistic background. What we found was very different. We found that there is no one type of genetic makeup that you can call Indian. So we really confirmed what Poet wrote in 1910, that India is indeed a melting pot of humanity. We found signatures of all types of population in the world. And what that did, I'm not pointing a laser because people online cannot see it. So I'll try to direct you to the map. So if you look at the northwest corner of the map, you expect those populations to be blue. So the pie charts, so the circles on the map are the genetic makeups. You expect them to be blue, but you notice somebody brown there, which should really be in the south. Similarly, you look at the south part, you see brown, but you also see blue, right? So you can't really tell that this is an Indian genome makeup if anything else is not Indian, right? So everybody was Indian, which really resonated with the philosophy of the country. The philosophy is that everybody is welcome, right? Nobody is an outsider. That's the philosophy of the country that I come from. And we merely confirmed all that philosophical understanding using very high level genetic research. This research was so impactful that it has like 5 or 6 pages in a contemporary history book that chronicles the history of India of the modern times. Right? It is written by a British historian called Patrick French, who passed away a couple of years ago, sadly. And I was very surprised and extremely proud that I am named by name in this book. And Patrick French devotes 2 pages on me. I don't know why, but I'm very happy that I'm very proud that I am named in a contemporary historical chronicle of my country. And this is what was the impact of this project for the country as a whole. It impacted positively. It removed a lot of the taboos of who we are and who we are close with, who we are not close with. It removed a lot of those taboos. That project also led to another project, which was scientifically, academically more interesting. So you're seeing the same map on the right top corner of the slide, and the arrow points to one particular pie chart, one particular circle on the map. That belonged to a population to the western part of India, where they look like the people you see on the slide. So they spoke Indian language, they had Indian rituals, they follow religions, local religions, but they looked like Africans. They played African drums and sang Indian music. It was a very surprising, very unique scenario. And the history is that their ancestors came as slaves with Portuguese people 200 years ago, came to India, and Portuguese left, they stayed on, and they mixed, they mated with local people, and the genomes, the genetic makeup became mixed between Africa and India, right? What you are seeing on the 2 graphs on the side is that each dot is one individual, and one individual point has about 50,000 genetic variants data compressed, just to give you the scale of the project. And you see the green on the left and the black on the right. So green on the left are the indigenous people from India. Black on the right are the original people from Africa. And in between the red dots are that people from the west part of India, which look like African but behave like Indians, right? So that created a social justice. How it created social justice? Until this project, and there are a few others who kind of came into the same conclusion, they were not recognized as citizens of India. Neither Africa recognized them nor India recognized them. They are outsider for everyone. This kind of project gave scientific proof that they are as much Indian genetically as any other Indian. Right? So that really changed. It is still happening. We are not there yet. So now people are picking it up. Films are being made, documentaries are being made. But it started from this kind of research. Not only our research, other people as well, which we also contributed to. So we are using genetics now to enrich lives for improving social justice. So that happened. The next story I want to tell about that, can you do it for a few families, maybe a community, maybe a neighborhood? So we did that in the Netherlands, where there are, you have a sense of how small Netherlands is, right, in the global context. So the map that you see is an enlarged Netherlands map, and the 5 circles are the 5 families who had the same disease. They were not related to each other as far as they knew, so they lived within 5 kilometers of each other. And our lab was where the arrow is, very close by. Right? And the disease was what you see on the right. So it's a picture of the eye, so it's an eye disease. The picture on the left side is a normal eye. The people on the right side is the person who is not normal. So if you see the vasculature, the vessels, how they don't go the same way, right? So that's the disease. Essentially, they are blind. So it's called Wagner disease. Disease name is not important here, but basically they were people who were formerly visually handicapped. There's nothing else wrong with their eye. This light didn't work the way it should. So my task, my primary job as a postdoctoral researcher was to find the gene that does this. Right? So we did find it, but not only we did find it, we also found a new genetic mechanism. So not only we found a new gene, we also found a new genetic mechanism. And I'm mindful that the audience, everybody would not understand the scientific terms. So I'll try to keep it non-technical. So most of the time when a genetic defect causes a disease, is usually something that should work, it doesn't work. So we call it a loss of function. Some other times it does something that is not supposed to do. So we call it a gain of function. So these are the 2 usual ways the genetic disease work. But here we found something completely different. What did we find? We find that this particular gene is called CSPG2. Again, the name doesn't really mean much. In normal condition, exist in 4 forms, 4 types. Both the normal and the person on the disease, which is on the right, has the same 4 forms. There is no gain of function or loss of function. What happens when they have the genetic defect that we found? The relative balance between these different forms changes. Something that should be up goes down, something that should be down goes up, right? And that was not known before this research, that you do not need a loss of function or a gain of function. Even within the existing normal forms of a particular gene, if the relative abundances vary, that can lead to a genetic disease, in this case causing blindness. So total number of molecules did not change. You did not lose anything, did not gain anything. So that was a new mechanism. So scientifically, it was we were very happy, and you can see the paper there. So I was the first author, and it's quite well cited. But it also enriched lives. Why? Because we were in the neighborhood. We met the people. We knew the families. They came and hugged us. They came and thanked us. So you could see, you could feel how you were changing their life. That to me is a more lasting memory than the pride of the scientific discovery. That made me more fulfilled. So that is the third story I want to talk to you about. So that's from population, we move to a few families, a community. Can you do it for an individual, a single individual? So this was also in the Netherlands. So this was one lady who was 41-year-old at the time, but her mental development was like a 10-year-old. And she had a smaller skull, we call it microcephaly technically, and her retina inside the eye was detached. So the pictures on the top are not the picture of the patient. They are stock images taken from Google, just to give you the impression that she would be looking like any one of those pictures, which not necessarily looks obviously anything wrong with the person. The picture at the bottom is actual picture of the retina from the patient. And she and her family just wanted to know why she has that problem. Is it something they did wrong? They felt guilty. The parents felt guilty. The lady, she felt guilty. And she just wanted to know. And I said yes, with having very little hope, because those of you who work in this kind of area knows that with one individual sample, it's almost impossible to crack the puzzle. You almost can never find out what is wrong. Luckily, we did find out what was wrong, right? I put up a lot of technical data, but don't worry about it. So in our cells, our DNA is spread out into number of threads. We call them chromosomes. And usually the chromosomes has to be in a certain order. They have to be packaged in a certain way. They have to be, their arrangement has to be in a specific way. For this particular lady, we found that one of our chromosomes, particularly chromosome 6, one copy. When I say one copy, what do I mean? You inherit one copy from your dad, one from your mom. So in this case, one of the two copies, one piece was flipped. Nothing was gained or nothing was lost, but one copy was flipped in its position. So as it flipped, it broken a gene down. Right? It broken a gene, so it doesn't function anymore. And what we found out in a model system, not in humans, that if you disrupt that gene, you actually affect neuronal branching, and that confirmed the phenotype, the observable characteristics we saw in the patient. And we could actually solve and help the family, enrich the family. We, of course, could not cure it, but we could tell them why it was, and it was not their fault. It was just a random stroke of bad luck, right? So we could tell them that. And again, what is a lasting memory for me is actually meeting this person before the project and as well as after the project. And again, how she reacted when we told her this is why you have what you have. The gratitude that I got is far bigger than any other award that I can get. So that's another story that enriched lives. The last story is where I'm going to spend most of the time, remaining time, and this is on glaucoma. So this is on a particular family and how this, our research on this family is changing the way glaucoma is managed. This is my longest running research interest in my academic career. I so far have published many papers, found 2 new genes, made 2 films that many of you know about, have a TED talk, and also inspired 1 novel, which I'm not going to talk about. Not written by me, somebody else wrote, a fiction based on my research. But it all started from another family member. I told you that I have a privilege of coming from an academic family. So the person who is shown in a bigger size of picture, Professor Ranabir Mukherjee, was a very renowned ophthalmologist in Calcutta. He is also my the eldest brother of my father. Right? So when I started PhD with Professor Kunal Ray, without knowing anything about genetics or biology, I went to him and said, you know, my supervisor has a background in eye genetics. What is the problem I should work on? Right? He said, the first gene for glaucoma has just been found out. That seems to be an interesting topic to work on. And I have ever since been working on that. So they are the inspiration. That's another privilege that I wanted to mention. So what happens when you have glaucoma? This is what you can see normally. So if you look at me, you are also seeing the side of the room. So if you have glaucoma, that peripheral vision reduces and you get a tunnel vision until you go blind. So after this next stage is you can't see at all. What makes glaucoma particularly dangerous is that it is usually painless, symptomless, and it is irreversible. Right? So you can't change it and you don't even realize you're losing it. That makes it very, very dangerous. So it started from a family. Let me explain how to read the different symbols if you are not familiar with it. So anything that is shown as a square is a male. Anything that shows in a circle is a female. Anything that is filled in black, they have glaucoma as a disease. They are blind. Anybody who is an open symbol, they're normal. Right? And anybody who is connected horizontally are partners. Anybody who are connected vertically are offsprings. Right? parents to children. So so if you draw it like that, you can follow the people filled in black, and you can see how the disease is moving in the family. So we found the mutation in the family long time ago. And if you notice in the last branch, the lowest branch of this family, you will see there are 3 individuals that are marked with a different symbol. There's an open symbol, open square or circle, but there's a line going through. These 3 individuals were children when we found them. They carried the mutation, but they did not yet show any phenotype. Right? So because of the knowledge of genetics, we could tell that they will for sure develop this disease later and become blind. But we couldn't do anything about it, right? Because until they showed symptom, doctors couldn't treat them. And by the time they showed symptom, it was too late because it was painless and irreversible. So by the time they realized and came to the clinic, they lost 70% of their vision. So nothing could be done. So they went blind, and I felt frustrated. Just to give you a context, this is the actual house where this family lives. Very, very poor, extremely poor. And they live 2 hours away from the nearest hospital. Right? Imagine a blind person having to take a bus for 2 hours coming to the city and visiting clinic and then going back. So the result is they often don't come. Right? So it was very distressing to see that. And I, again, me being passionate about meeting the people I work with, meeting the patient, I went to their village, I interacted with them. I still do when I go back to India. I meet with them regularly whenever I can. And then what I did in 2023, and funding from Salford University, we went to that village and we did a workshop with the patients and the villagers. And we decided to tell the story in a fictional form rather than telling the scientific way. And then led to a film. And you see the left is the workshop, one of the snap from the workshop, and the right, actually the shooting team is getting ready for a shoot. It happened in that village in front of their home. So of course they couldn't see, many of them were blind, but they were part of it very much, right? So we wanted to be authentic, and we wanted to tell the story in a different way. And I'll tell you in a few minutes why in a different way. That led to a film called Vision of the Blind Lady. This is on YouTube. Many of you have seen it. If not, please do. So that film has started to change things. How? The people, the doctors, the charitable organizations, the eye hospitals who did not understand what I was trying to say, who did not listen to me when I talked to them using scientific language, they now started taking action. They now got moved because the story was told in a different way. Right? Because instead of appealing to their logical mind, I appeal to their emotion. I made them feel rather than trying to make them understand. So what happened is a team first came to the village. They seen the patients. They understood the problem. They invited some of them to come to the city. Rotary, you all know Rotary as a large charity. Rotary came in and solved the problem of transportation. Again, I was out of the picture. It was now in an autopilot mode. And then people were treated. This is just one story. There are multiple now. There's one story where a boy was treated who has the mutation before the disease was full blown, just started showing symptoms. And the boy was surgically intervened on. And this was 1.5 years ago. And he is now glaucoma free. So we managed to prevent the disease from happening. And that is now shown in a second movie called Ripples of Light, which is also on YouTube. So please go and see that. So what happened in the family? The same family I showed you before in a shorter form. You can still notice those 3 individuals that a line goes to them. So they now became blind as we predicted. Right? We knew that will happen. But now they are parents themselves. So each one of them has a son. And all 3 sons are carrying that mutation, and they are exactly at the same stage where their parents were 20 years. Right? So they have the mutation and they are not yet showing the disease. But now, thanks to the movie, all of the 3 are being operated on, and they are now doing fine for over a year now. Right? And So I talk about it more in a TED talk that I did a couple of years ago. So again, that is also on YouTube. And please go and watch it to know more about this particular project. And I'm very, very happy and proud that this particular work is still supported by the University of Salford. And this is now changing policy of glaucoma management in India. And I'm working together with collaborators that I showed you earlier. And we are making it as a policy that is not restricted within one family. So it is accessible to all families as much as possible. Whenever there's a genetic case of glaucoma, so that there can be intervened early, so that their sight can be saved, right? So this is a direct result of storytelling. Now, why storytelling matters in genetic diseases? It matters because this is from a survey based in the US, but I'll give you the numbers. For one individual, if they have a genetic disease, managing them cost about 220,000 US dollars in a lifetime of one individual. And usually a diagnosis and starting of treatment takes about 6 years, right? And 17 doctors visit. So no wonder the family I showed, they will go blind before anything can happen. So if you tell story, and if the story moves people to act sooner, act faster, you are saving that crucial time and diagnosing early and changing their life, hopefully preventing the disease. So that's why storytelling matters in genetic diseases, because when you tell stories, something very different happens to the brain. When you talk about science, you try to understand with your logical portion of your brain that cannot feel, that only understand language, right? When you tell stories, the one that we told, and you appeal to the emotional center of your brain, the whole brain gets engaged, right? You are motivated to take action, right? Think of all the things that is driver for whatever you do. You will find out at the back of it, there is some feeling associated, not a fact. Usually there will be a feeling, there will be a reason why you do what you do, right? So that's why storytelling is so very important for genetic diseases, for changing lives and enriching lives. So that's my drive. And how can I tell stories? So I'm towards the end of the talk. So just to kind of wrap it up, I'm very, very grateful that I have a job where I have the privilege to fail, I have the luxury to fail. Anybody who has gone through life knows that success is never a linear line. You fail more times than you succeed. So if we avoid the journey rather than the destination, I think it will be much more fulfilling. And I'm just very fortunate that University of Salford happens to have a vision that directly aligns what I'm trying to do. University of Salford, the vision is that you innovate to enrich lives, which is what I've been trying to do. So it's a very nice coincidence for me that I work here. That's fantastic. So I'll end with my personal philosophy. The arrow points to somewhere in Manchester. We are very zoomed into this particular room, which is a tiny speck in the world. If you zoom out, we are a tiny speck in the universe. We are a very fragile, pale blue dot in an infinite universe. We're trying to grapple with the existential angst that what our finite lives mean in an infinite universe. Our energies are infinite. And so I hope that you appreciate that rather than the destination, the journey through love, curiosity, and care is much more meaningful. That's what drives me. I hope that drives you. Thank you. I close here. Happy to take any question.
Thank you, Arijit. What a fascinating talk. I'm sure you'll all agree. Can I now just open the flow to questions?
We are now entering an age where more and more disease will be known by their genotypes. Now, what stage are we in globally in terms of this genotypic and phenotypic correlation?
How much time have you had?
Arjit, could you repeat the
Yeah.
question for the
I'll repeat
online?
question. So the question is, now that genetic information is becoming the forefront of healthcare, very much in the UK, also all over the world, how far are we in making that a reality? We travel quite far, but again, it's a journey, not a destination. So we have not reached in any culmination point, in the sense there are many, many genetic diseases that we have no idea what is the genotype-phenotype correlation. We understand by epidemiological studies and by family studies that a significant part of those diseases are controlled by genes, but they're so complex and they are so much of interplay between environment and genes that we can't really solve that puzzle. The only puzzles that we can solve so far, some of the examples I showed, and there are many other examples, other research groups, where there is a single genetic change can determine the outcome. So it's relatively simpler puzzles can be solved. And now with genome editing in place, hopefully can be cured as well in the future. Not all of them, some of them. But in the global scheme of things, which you've got all diseases that are genetic underpinning, we are not even close to any value.
So there's a question online, Arjit. What was the toughest decision in your career and how did you go through the process?
I'll mention one. There are quite a few. The toughest decision was when as I told you that it was 3 years after my master that I started my PhD in genetics without doing anything. And when 2 months or 3 months into the PhD, when nothing made sense to me, I got a call from my previous chemistry lab that they now have a funded position for me, PhD position. It is mine if I want it. I couldn't decide. I spent like a week of sleepless nights. I couldn't know what to do. And eventually I tossed a coin. And as they say, when you toss a coin, your subconscious knows, even if you consciously don't know. And I tossed a coin. I said, head I stay, tail I go. It was heads. I think if it was tail, I would still have stayed, but I don't know. That was one of the toughest decisions. There are a few more, but that's probably the toughest.
Any more questions?
Yeah, for sure.
Could you repeat the
So
question?
the question is that when I say, quote Heraclitus, and say that change is the only constant, how do I see it in a broader scheme of things, right? But as you rightly said, it's an Eastern way of thinking and a Western way of thinking. So the Eastern way of thinking is that death is not the end. Death is a stop in the journey that is infinite, right? And it's the change that only matters, right? So I kind of believe in it, not in a religious way, but in a spiritual way. I believe in it, and I think if you add that, as you mentioned, East and West combination, if you mix that philosophy into the Western philosophy of how do you say, be productive, and that really kind of brings the best, I think, in the two things. And I'll make a lighter comment, if I may. I come from places that are extremely chaotic, right? Nothing happens on time, right? There's everything is honking, everything is late, everybody's rushing, but still everybody is late, right? And it still somehow works, right? So the chaos, so the order in chaos is something we naturally grow up with. So change motivates me rather than unnerving me. So that I think works in my advantage when there is a shift or a change or chaos, whether it's a COVID or it's a university restructuring, I quite enjoy going through it. So I guess that's the Eastern philosophy coming into play to survive in a Western system. Thank you.
Sarah?
So the question is that that my current research, those who know about it, is not what I'm talking about today, except the part of the glaucoma work. So I do something very, very molecular, which will be boring for a wider audience. So the question is, am I going to work on genetic disease in Manchester? Answer is yes, I would love to. And I landed up on what I do kind of little bit by force. Not by, so I tried to work on genetic diseases, on human conditions. I found it complicated to work within the system. And then on the side, this field was happening. So I just started working in this field. It became more doable, logistically, practically, given the limitations we all work in. So that's the reason. But yes, definitely, I'm actually talking as we speak to some clinicians in Manchester to see whether we can do some of the genetic stories here. So yes, I would love to, but it's much more difficult given our limitations.
Right. One last quick question.
Yes, the question is whether my insight into storytelling changed how I teach. Definitely. Insight, and especially this film that I talked about, I first started talking about in 2022 with then first year students. They have graduated by now. But then first year students. And previously also, the story I told you, I always told that story in the class for first year students. And I was surprised every time when I met them after, they might be doing a job, after they left the university, they always, when they met me, they always remembered that story. They've forgotten everything else. Right? So that kept on telling me that, okay, this is the bit they remember. They don't remember the science. They remember how their family felt. They remember how the mother hugged me when I told them that I know why you have this. So that's what led me thinking about storytelling. And yes, it definitely changed. Now that I saw the impact of storytelling, the impact of making people feel and how that helped people understand. And that definitely changed the way I do anything really, including teaching.
And that's why he's a fabulous teacher as well. Yes, I had to bring this to a close, but before we finish, there's a token of appreciation for you, Arijit. And could I invite our Dean to be, Professor Vicky Halliwell? So just to end off with a few acknowledgements to the University of Salford for, of course, allowing us to host this event. Lucy Buckingham and the events team for all the fabulous organization that has gone in. The DIT team for the tech support, the catering teams and Chapman Cafe. You're about to see what they have done. And of course, last but not least, family, friends, colleagues, all of you who are here in person and also those online. Thank you so much because you made it a wonderful event. And thank you, Arijit, for a fascinating insights. Could I please invite you to take part in some refreshments outside? Thank you.